Don't erase it. So, you see that whole graph that I set up for you? I don't want you to erase it. You just need to modify it, and also part C, you're supposed to graph something. I don't see one graph. You guys gotta read more carefully. All right, so this is a review of the last lesson, part A. Give me the equation that's going to represent this scenario. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll start with Kayla in the back, and then Janae. What'd you get? Okay. So you both basically say the same thing, and that is exactly what I was looking for. C equals 30t plus 50. Outstanding. Next, I ask you to graph the equation. I'm just going to reveal the graph. Can't really call volunteers for it. That is the graph that I was expecting. I provided the grid for you. It's perfectly set up for you right here. All you had to do was graph this equation. I would like someone to somehow transport themselves inside Mr. Gowd's brain and predict the reason why he thinks that the equation was so easy to graph. Why was it so easy to graph? Nathaniel?
Because you gave us the graph.
Okay, but what?
And the graph.
Good, that's one reason. Valerie? I did? Yeah, because it's in what form?
Slope.
What is it called?
Slope-intercept.
It's not called slope form, no. What is the form called?
Slope-intercept.
This is slope-intercept form. This is unbelievably easy to graph. There's the y-intercept right there. Rise 30 over 1. Rise 30 over 1. Rise and run. Part C. Suppose the plumber raises the charge to $32 per hour. Graph a new equation in the same coordinate plane on the same graph. So I was expecting that line to appear on your graph. It has the same exact y-intercept because the new equation is C equals 32t plus 50. So the only difference is that the slope is different. The purplish pink line is a steeper line than the red line because the slope is greater. So, comments, questions on anything from today's warm-up? Comments or questions? Okay, give me a thumbs up if you got part A correct. Good, put your thumbs down. All right, that's a good start. Are there any comments or questions? Today your goal is to understand the concept of a direct variation. So now I'm introducing a whole new phrase that you have to get to know. A direct variation is a type of linear equation. It's not a form. Slope-intercept form was a way of writing a linear equation. A direct variation is a type of linear equation. Actually, compared to what you studied last time, it's actually easier. The parts that get a little frustrating for students is that I'm going to use new words. We're going to be using some new variables. But it is in actuality the same thing that you've been studying all along. So first of all, what does a direct variation look like when it's graphed? Here are two examples. The graphs have one major detail in common. So I'd like you to take a moment to look at the two graphs, compare them with each other. What major detail do they have in common? Could you?
One's positive, one's negative.
Okay. Well, that's a contrast. So you looked at them and you told us what was different about them, and that was very good. That one's positive, has positive, so one has negative. But my question was actually, what do they have in common? So comparing, Shannon?
The line's bigger than the
Very good. Could someone use a technical term to describe what she was describing? Stephanie? Very good. They both pass through the origin, which is what Shannon was saying. They both pass through the middle. A direct variation always passes through the middle. Always. So if you have an equation that's in slope-intercept form, and then you graph it, and you see that the line goes through the origin, it's a direct variation. So, what is the definition of a direct variation? This is a very technical definition, but there's couple of important pieces to pull out. First of all, a direct variation might also be stated as two quantities varying directly, so you might see it said this way. And we're going to be using the model y equals kx. A line through the origin always represents a direct variation. That's what we just talked about. So we're going to start using this model y equals kx, and some of my students year after year start flipping out. Well, what does he mean k? What do you mean y equals kx? I have no idea what's going on. So let me back up for a second and write down something that we learned last time. We learned y equals mx plus b. Could someone remind us, what is that called? It has a name. John? Okay, well, you actually, and I don't mean to cut you off, and I'm not trying to be rude, but it's got to be like instant recall. You should already know what it's called. If you don't, then you got to get that committed to memory. Alexandra? This is called slope-intercept form, and next time when you say it, Alexandra, don't say it with a question mark at the end. Slope-intercept form? Yes, it's slope-intercept form. You should know it confidently with no hesitation. This is called slope-intercept form. So now I'm going to write this model, y equals kx. So now look, we've got y, we've got equals, we've got an x, we've got a letter here. It's a different letter, but it's in the same position. What's the only thing that's really different about the two models? Edgar? Good. So could someone refresh our memory? What is B? What does this stand for? Valerie? Y-intercept. So could someone explain why there's no y-intercept here? Why is there no y-intercept right there? Fung? Yeah. So say it differently. The y-intercept is... Yeah, the y-intercept is there. It's just 0. So in actuality, these are the exact same thing, except we won't ever have to worry about a y-intercept because it's always 0. Okay? So here is a real-world example of a direct variation. If you think about cars that are driving on roads and car accidents, you would expect that if the number of cars driving around increased, the number of accidents would increase. So as one number goes up, the other number goes up. That is a possible example of a direct variation. Are there any comments, questions so far? All right. The constant of variation. Again, big fancy phrase, constant of variation. It's almost like you're in a high school AP class all of a sudden. You've got these really high level terms. The constant of variation is K. Can someone who's working at a high level this afternoon and looking at what I've written out so far give us another word or phrase that is synonymous with constant of variation? What's another word or phrase that means the same thing as constant of variation? Michaela?
Variable.
Well, it is represented by a variable, but lots of things are represented by a variable. So there's something else very specific that is the same thing as constant of variation. Dalton?
Intercept.
Not intercepts, no. You didn't look up here.
Oh.
I mean, it should really jump out at you. Ziomara? Slope. Constant of variation is slope. It's in the same exact position as slope in the model. It's slope. It's the same thing. So I will actually not use this phrase very much at all. I might have it in the instructions here or there, but for the rest of the year, I probably won't say constant of variation. I will say slope. You have to know that constant of variation is the same thing as slope. On the EOC at the end of the year in May, you're going to have a question or two that says, what's the constant of variation in this direct variation model? Wow, that's really complicated sounding. But what it really means is, what's the slope? So you have to know that they're the same thing. Now, as I always do, I outline for you in a sequence of steps how to be successful. So I'm going to help you learn how to write a direct variation model. Step number 1, substitute the values of x and y into the model and solve for k. Once you have k, then you plug k back into the model and you have an equation. So writing a direct variation model is only 2 steps. And you're going to see that there's actually a lot of shortcuts that you can take. And I'm not going to discuss the shortcuts. I will a tiny bit later on, but for the most part, the shortcuts are there for you to find. It's for my higher level students to discover and then use. You won't know if you've discovered a shortcut until you've seen it a couple of times. But once you discover a shortcut, you're more than welcome to use it as often as you would like. So we're going to jump right in and start writing direct variation models with some information that we're given. If you're missing anything from notes, of course, you can just leave yourself a couple of lines of space and we'll fill it in a little bit later. So, I do not want you to write these instructions. I want you to read them carefully, because you're going to see them in the workbook and in the textbook. Then we're going to learn how to write a direct variation model. So we're told that x and y vary directly. That means that it's a direct variation. But we're only given one value of x and one value of y, and we have to write an equation from that. It's actually a simple process. It's all based on this model, y equals kx. And it's very simple, actually. We have a value of x, and we have an x. We have a value for y, we have a y. We don't have k, but that's what we want to find. Once we fill in all the information, we can solve a simple equation to find k. So we're going to plug -6 in place of y. K is what we're looking for. And x is 15. Solve the equation. I'm sorry, this is step 1. Solve the equation. Well, that's a simple equation to solve. How do we solve that? Only 4 people can do it, or everyone's already doing it? Sebastian in the back? Very good. Divide both sides by 15. Don't write a decimal. Just put this fraction in simplest form. So what will k equal? What will k equal? Davis?
-6/15.
Okay, but that's not in simplest form, so we always put things in simplest form. So unfortunately, I would mark that wrong. Valerie? Close. Danielle? I'm sorry? Yes, it's -2/5. So, that's step number 1. We found the value of k is -2/5. If you have no idea how Danielle got -2/5, then you have to do some fraction work on your own. So now, step 2. We're using this model again, and it's very simple. Take this number and plug it in here, and that's it. Y equals -2/5 x. And now we have written an equation that models this direct variation. Comments or questions on how we did that 2-step process? Good. So let's make sure we're understanding part B. X is -50, y is 75, and we know that they vary directly. So once you hear that they vary directly, you should immediately be thinking y equals kx. Yes, Nathaniel? You're good? Okay, well, give us a chance to catch up to you. Step 1, we need to find k, so we're going to plug in the information. 75 equals k times -50. So what will k equal? What will k equal? Go ahead, Nathaniel.
-1 and 1/2.
-1 and 1/2, but we don't want to write it like that.
Oh.
So how should we write it?
75
No, there's a reason why I don't want it as -1 and 1/2. If you think about what k really is,
Oh, -1 and 1/2.
you still can't do that. Danielle, she's going to help you out. -3/2. -3/2, because k is the same thing as slope. We don't want it in mixed number form. It has to be as a fraction. So the next part is easy. Step 2 is just take this value and plug it in for k. Y equals -3/2x. And that is the equation we were looking for. Compared to other things you've studied in this class, this is not really that complex yet. Now, I will tell you the biggest issue that I have year after year is students don't finish the job. Year after year, I have students who do their classwork and their homework, and this is where they stop. They find K, and then they think they're done. And I understand why, because it seems like, oh, I got a letter equals a number, that means I'm done. But I'm asking you to write an equation. If you don't do this step, it will be marked wrong. So make sure you completely follow the process. Are there any questions or comments on what we've done so far? Good, let's see how you do on your own. Checkpoint number 1. You got one question. Got a minute and a half. All right, what equation did you get? Got 1, 2, 3 confident people, 4, 5 confident people, 6 confident, 9 confident people, and about 11 people hoping that I don't call them. Okay, so we'll start with Sebastian, then we will go to Alexandra, and then we will go to Michaela, and then Kalasia.
Y equals negative 2 over 1x.
Okay. Who's next?
Y equals negative 2 over 1x.
Okay, so you got the same thing. Who was next? Go ahead.
Y equals negative
Okay. So you all basically got the same thing. That's good because that's correct. Y equals negative 2x. Y equals negative 2 over 1x is great as well. Comments or questions? Yes? Okay. All right, so now we take what we've learned and go to the next level. So, this is another way that it will be written in certain instructions. Assume the variables vary directly, or the variables do vary directly, or it'll be something about direct variation or varying directly. So now, we want to use an equation to find a missing value. So it says if x equals 16 when y equals negative 18, find x when y is 36. So we're actually going to follow the exact same process. Let me see if I can make it easier for you to see. If I eliminate that part from the question, we can find a direct variation model for those values. So that's what we're going to do first. So we have the model y equals kx. We have x and y, we need k. So we're going to follow the same process. My students who found the shortcut, you could skip over an entire step. You have the shortcut figured out. If you don't worry about it. Negative 18 equals k times 16. K will equal what? Only one person can do that next part? I'm sorry, am I going too fast, or we're all sitting here doing nothing? Okay, good. Awesome. Okay, so let's see. What does it come out to? Danielle, what does it come out to? Excellent. K equals negative 9/8. Outstanding. Not a big deal. But we need an equation. That's just a value for K. So now we have to plug that back into the y equals kx, and we get y equals negative 9/8 x. So we got the equation. But then we have another part now. We are now being asked to find another value when y is 36. So now we are going to use this equation to find a value. Y is now 36, so plug in a 36 equals negative 9/8 x, and now solve for x. How do I solve an equation that has a rational or fractional coefficient? How do I deal with that? 5, 6, 7. Pump. Simplify? How? Okay, so just reciprocal? You're definitely onto something, but we need full explanation so all my wonderful students in the room can understand. Danielle is going to take over for you. Good. Multiply by the reciprocal. So we're going to multiply by negative 8/9 and multiply by negative 8/9. And that's easy to do. This cancels this, and we get x equals what? Got 1, 2, 3, 4. Alexandra, then John. What'd you get? Okay, what'd you get? Negative 32. That is correct. And that was what we were actually asked to find. Was this value of x. Find x. Now we found it. To find it, we had to do this so that we had something to plug into. Any questions on this process? Okay, before we go on to another checkpoint, give me a thumbs up if you think you found a shortcut to find K. Give me a thumbs up if you found a shortcut. 2 people? Okay. If you're not looking for it, then you're never going to find it. Checkpoint number 2. See how you do on your own. that only works for direct variation. Good. All right, what's the value of x? The value of x. We'll start with Michaela, Edgar, then Ziomara, and then Matthew. Okay. -3, you said? Same thing as her, as Ziomara? So 3 people agree, Matthew? -3, everybody agrees. That's because the answer is -3, and to get it, that was the model that you needed to write. Y equals -7x. And then when you plug in 21, you get -3. Comments, questions on checkpoint number 2? Well, let me back up. Give me a thumbs up if you got checkpoint 2 correct. Okay, put your thumbs down. Are there any questions? Okay. Shannon, now that you see the answer, can you go backwards and find where you went wrong? You found where you went wrong already? Good for you. Kayla, did you find where you went wrong? Okay. That was kind of a cryptic answer, but all right. We'll move forward and I'll see if I can help you individually. All right, so we've learned everything new. Now we're just going to apply it in a couple of different ways. So, example 3, how to work with direct variation when we are given a graph. I don't need you to draw the graph. I don't need you to write the instructions, but of course you have to write what we do together. So, we have a direct variation graphed. We're asked to first write the direct variation equation, then find the value of y when x is 10. Now, if you've been paying attention for the last month, we could use a graph to do this, because if this graph was extended up to here, we could go over to 10 and then just follow it up until we hit the graph, and that would tell us the y value. But the problem is that the graph is not big enough. So we need the equation so that we can find that value. So we're going to use the model again. Y equals kx. Excuse me. Y equals kx. And we need a point to plug in, and we see a point right here. But there's actually an easier way. We really need k. Danielle, could you remind us again, k is the same thing as what? A slope. Very good. I called on her several times because she was the one who pointed it out earlier. Is there a way to find the slope just by looking at the picture and just thinking about it? 3 people have an idea? 4 people? 6 people? 7 people? Nathaniel?
You could see that you have to rise 1 and 1/2. So you get to the next point and then run to 1. You get the next point on the line.
Okay. So you said an important word. What was that word that you said? You find the what?
Find the rise and run.
The rise and the run. Very good. Now you went from here, I think you were saying, to the next point, but actually that's hard, right? That's hard to figure out. There's actually a really good point to use that we could find a very easy rise over run. Dalton seems anxiously to want to tell us.
0.
Yeah, 0, 0, right here. Boom. Rise from here to here. 1, 2, 3, 4, 5, 6, 7. That's a rise of 7. Now run. 1, 2, 3, 4. That's a run of 4. Rise over run. 7 over 4. So there's really not much effort needed if you're given a good graph. Y equals 7/4 x. So we were asked to write the direct variation equation for this graph. This is it. This is an equation of that graph. Then we're asked to find the value of y when x is 10. So that's easy. Plug in a 10. Y equals 7/4 times 10. That's pretty darn easy. You already figured it out? Okay, go ahead. Yeah. It's 35 halves. We get y equals 35 halves. Or you could say 17 and a half. Either way is acceptable. So you have to, one of the major points here is that some of my students think that, okay, direct variation is this idea over here. And then slope-intercept form is the idea over there. And a graph is this idea up there. And then the other graphs that we did a week ago are this idea over here. But what my students need to make sure they understand is that it's all the same thing. We've been talking about the same exact thing in different ways. That's it. It's the same exact thing. Okay? Dalton, go ahead.
Can you do it a different way?
It's probably 5 different ways we can do it.
Yeah, -4 and -7, right? Just put them over each other. There's 2 negatives, so you just negative.
That's right. And that's going to be important for the next question. So now, part B is the only one that's a little bit different than all the others. This time you do have to copy the table because it's not going to make sense unless you do. This question is different than the rest because this is the first time we are being asked to tell whether something is a direct variation. All of the other questions, we were told first that it was a direct variation and then we were asked to proceed from there. This time we're given some data and we're asked to figure out if it's a direct variation. There's a simple way to tell if something is a direct variation based on a table of data. We just have to find k. If k is the same for all of these points, then it's a direct variation. And so now we need to know who discovered the shortcut. What is the shortcut for finding out k? What's the shortcut? Davis? Okay. Well, Davis is going to have a kick himself moment in about 30 seconds. Sebastian? I'm sorry? You got the right idea. Unfortunately, you messed up a little bit. Kadir? Yeah, it's y over x. Davis is kicking himself because he told me that very same fact about 5 minutes ago and did not realize it. But k is y over x. Let's rewind and see how that happened. Y is k over x. Y is k over x. I'm sorry. K is y over x. I totally butchered that. Y over x. Look, y over x. Y over x. Simplified. It's y over x every time. Y over x. Simplified every time. K is y over x. Y over x. Simplified every time. So finding k is actually very easy. So we're going to put y over x, 14 over -4, and then put it in simplest form. What will that be in simplest form? Alexandra?
7 over -2.
Yeah, -7 halves. Very good. Now let's do the next one. 7 over negative 2. Well, that's already in simplest form. It's negative 7 halves. Let's do the next one. Negative 7 over 2. It's already in simplest form. Negative 7 halves. Is k the same for all of them? Yeah, so that means that this is a direct variation model. If we keep checking, we will see that they all come out to negative 7 over 2. Negative 7 over 2. So now we have checked, and we now can say that yes, this is a direct variation. And then we are asked, if it is, write the direct variation equation. Well, we already know what k is. Y equals negative 7 halves x. Comments or questions on this one? Okay, I do have one more example, but we're not going to do it. I just want to show you quickly that this actually does come up in the world of, actually in a lot of different areas of our world, but here's a science example. There's a law called Hooke's law that is a direct variation. It has to do with the stretching a spring and the amount of force required to stretch it. Is a direct variation, and you can do a lot of calculations with that. So that's just a real-world application of it, but it's still executed the same way. But I'd rather give you time to work, so draw a line across your paper. Your classwork is on page 43. You're going to do numbers 34, 28, 20, 13, 7, and 2. Okay, colored pens up. Let's see how we are doing with direct variation so far. Number 34, part A is actually down here at the bottom. Part B is right here. Part C is right here. Check your answers carefully. You can mark each one separately, so you got 3 different answers there. Number 28, y equals negative 3/8 x. For number 20, and I'm sorry my answer got a little bit cut off. Yes, this is a direct variation, and you get y equals 0.4x, or you could have put y equals 2/5 x. That's what I would have put, but I got this from the publisher. And then number 13, sorry, let me move this a little bit. Number 13, that was an easy one. You just had to look at the graph and find the slope. Y equals 1/2 x, and then you had to find a value from that. The value was 5. Number 7, you had to graph, but you had to put it into slope-intercept form or direct variation form first. And then number 2 was the last question, and the answer was no. Comments or questions on any of these, on how they were done, where these answers came from? We'll start with Kayla in the back and then John. Kayla, which number? Number 28, very good. If everyone will look at their number 28, please. Give me a thumbs up if you got number 28 correct. Good, put your thumbs down. That was a lot of us. So you were asked to write a direct variation model. You have two choices. You can follow my sequence of steps, or you can use the shortcut. Could someone remind us of the shortcut to finding K? What's the shortcut to calculate K without really having to put forth much effort? Shannon?
Y over X.
Yeah, it's y over x. So it's negative 3 over 8, and then just put it in simplest form. But then you are asked to write an equation. So y equals negative 3/8 x is the equation you get from that. Okay? So where did we go wrong? What was the issue? Perfectly simple, reasonable little mistake. Not a big deal. Okay, John, your question? Number 20. Number 20. Give me a thumbs up if you got number 20 correct. Good. Put your thumbs down. Stephanie, what's the first thing you did when you tried to solve this? Okay. And what does that get you? What are you finding when you do that? No, I know, but I'm saying what are you trying to find when you do that process? You're telling me the answer, I'm telling you what are you trying to find? It's going to be another kick yourself moment. What was she trying to find, Kadir?
All of the coordinates if the slope of the
Yeah, we're trying to find the slope or the K value. So this is now 2/5. Now we need to do that with all of them. 1.2 over 3 comes out to 0.4, but 0.4 is actually the same thing as 2/5. And then negative 0.8 over negative 2 comes out to 0.4, but that's the same thing as 2/5. And they all come out to 2/5. And that's why you get this right here. Okay? So John, did I answer your question?
It's not what I did. It was just a simple mistake because I divided 3 by 1.2 instead of 1.2.
Okay, but that's actually important because that's a mistake that a lot of students make. So we can't do that. You have to know that K is y over x. Otherwise, think of it this way. You tried to use a shortcut and you used the wrong shortcut. So are you allowed to use it? No. Then you have to go back to the steps that I outlined in the notes and you use that process. Yes.
I didn't get to do this. I just wanted to.
Number 2. Well, I actually don't have it up here, but the question is that what is it a direct variation? So number 2, I believe, was y equals 2x plus 1. The answer is no, it's not a direct variation. Can someone explain in simple terms why it is not a direct variation? Why is it not? Zumara? Because it has a y-intercept other than 0. That's it. Direct variations will have a 0 or nothing there. Good. Draw a line across your paper. Your homework is 4 through 36 even and 40 through 44 even. That's 21 questions. You're going to read the next section. And your test on chapter 4 will be on Tuesday. Next week.
No,